Hey guys, so today we're going to look at how to solve equations that involve algebraic fractions. So if you think back at the beginning of the year, we learned about clearing the fraction. That's basically what we're going to be doing here, is we're going to be clearing the fraction. And this is the reason why earlier in the school year I said you can't try to get a common denominator. You have to try to clear out the fractions, because that's the skill you need here when your denominators are algebraic expressions. Okay, so the way we're going to approach this is we're going to look at our equations and look at our denominators and try to find the least common multiple of your denominators. So if I look at example 1, 6 and 3 both go into 6. Your least common multiple here is going to be 6. And then the highest exponent that I have for my x's is x squared. So they all go into x squared. That's what I'm going to multiply every term by. So I'm going to multiply this by 6x squared, this one by 6x squared, and this by 6x squared. And your goal is to clear the fractions. So in the first fraction, these cancel out completely. So I'm left with a 1. In the second fraction, 3 goes into 6 twice, and x squared cancels out completely, and I multiply. 2 times 1 is 2. And in the third one, I have minus x goes into x squared x times. I'm left with 1 times 6x, which is 6x. And the idea is that in the second line of your work here, you should have no more fractions, and you're just solving. Now, sometimes you're going to be left with a linear. Sometimes you'll be left with a quadratic equation. If it's linear, obviously you get your x's on one side and your numbers on the other. If it's a quadratic, you have to set equal to 0 and then factor and solve. So this is linear. I'm going to subtract 2 on each side. I have negative 1 equals negative 6x. Divide both sides by negative 6. I have x equals positive 1/6. Okay, go to example 2. I'm looking at a least common multiple here of my denominators of the highest exponent that the variables have is c squared. So I'm going to multiply every term by c squared. So c squared cancels here. I have a 5. C goes into c squared c times. I multiply 6 times c, 6c. Minus 1 times c squared is c squared. This is a quadratic. So since it's a quadratic, I have to set it equal to 0. I'm going to subtract the 5. I now have, all right, so I have 0 equals negative c squared plus 6c minus 5. I don't want to have my c squared to be negative. That's why I kind of was thinking out loud. So what I'm going to do is I'm going to multiply everything by negative 1. And that'll turn my c squared positive. So, and I'm also going to reverse the order where I'm going to put the equals 0 on this side. So I'll have c squared minus 6c plus 5 equal to 0. I look for a GCF. There is none. I factor into 2 binomials. I have c times c and 1 times 5. They will both be negative. So I have c minus 1 equals 0 or c minus 5 equals 0. So c equals 1 or c equals 5. What you want to check at the end of your problem, is if your two answers, if you were to plug them into your denominators back into the original equation, if any of them would produce a 0 in the denominator. If so, you reject those values. So if I plug a 1 in here for c or a 5 in, they don't produce 0. So I'm good. I accept both answers. Okay. The next one, I look at my denominators. I have, I don't know why it does this. Okay. I'm going to just do it this way, I guess. I have 4n squared would be my least common multiple. Okay. So I'm going to multiply everything by 4n squared, 4n squared, 4n squared. This cancels. I have 3n plus 15. N squared cancels with n squared. I'm left with a 4. So 4 times 1 is 4. Minus 4n squared cancels completely. Be careful that minus distributes to the n minus 3. That's an important thing. So I have 3n plus 15 equals 4 minus n plus 3. That's going to give us 3n plus 15 equals 7 minus n. This is linear, so just get your n's on the left side. So I'll add n, and I'll subtract 15. So I have 4n is equal to negative 8. Divide by 4, n equals negative 2. And I just double check. If I plug the negative 2 into my denominators, none of them would produce 0, so I don't reject any answers.